Okay, in this video we'll be explaining logic gates. First, we'll be looking at an AND gate. Uh, First, we're gonna set up the circuit for replacing a 1 kilo ohm resistor here, like that. Okay, then we set up a transistor from here, from where we place the transistor, from where we place the 1 kilo ohm resistor, right there. And we're leaving one space between each leg. Okay, and then we're gonna place a second one for the AND gate from here to here. We left 4 spaces in between each transistor. I place them backwards. After placing both, we'll place an LED light from the last leg on the second transistor. We place the long leg at the last leg, and we connect the small leg to the ground, just like that. Now we will use a jumper cable from the last leg in the first transistor to the first leg in the second transistor. Now, using a 9-volt battery, we connect it to the Lego Uno power supply. Then we'll use a red jumper cable connected to the 5 volts. So 5 volt. And then we'll use a white one connected to the ground. Now we connect the white one to the ground. To the ground. And the red one to a voltage source. And right now the LED is off because there's no switch connected. Now, using a red jumper cable, I will create a switch from the resistor, which is also where the first leg is of the first transistor is. We'll connect it, and then we will connect it to the middle leg, which still won't work because since we have 2 transistors, both transistors have to have a switch connected, because if not, the current won't be passing through. Now, using another jumper cable, we will connect the first leg of the second transistor and the second leg. Good. Oh. They're connecting the second power. If they're connecting the second switch, we obtain this result. The LED is on. Just like in the previous ones where there was one switch connected, the LED was off because the current was enclosed. And when we had none, well, we have 0 switches on, and we need a 2 for an AND gate to turn on the LED. Now we will look at an OR gate, starting from this setup. The 9-volt battery connected to the jumper cables to a power supply, and then 2 jumper cables connecting from the 5-volt port and the ground bolt to the voltage source and to the ground, and the resistor connected from the voltage source to the first leg of the first resistor. Now we will connect the jumper cable from the first leg in the first resistor to the first leg in the second resistor, and another jumper cable from the last leg in the second resistor to the last leg in the second resistor. Now that we have this, we will use another jumper cable to create a switch in the first resistor, in the first transistor. We will connect it from the resistor to the second leg in the first resistor. And since it's an OR gate, it doesn't matter where we put the switch. We just need one switch to light the LED. Like we saw before, when there was no switch, there was no jumper cable connecting the resistor to the middle leg, the LED was off. In an OR gate, we just need to place the jumper cable, in this case we consider it a switch, from the resistor and the first leg of the transistor to the middle leg of the transistor. It doesn't matter in which transistor we place it, so I will just show. Right now it was in the first transistor. Now we connect it into the second transistor, and as I just showed, the LED turns on. This is a NOR gate. Now we will go over a NOT gate. In a NOT gate, starting from this setup, the 9-volt variety to the power supply to the breadboard, and then the voltage into the resistor and then into the transistor. We will use a jumper cable from the first leg in the transistor to the long leg in the LED. As we see, when there is no switch connected, the LED will be on. Now, when we connect a switch from the resistor to the middle leg, when we put a switch, in this case a jumper cable, from the resistor to the middle leg, and another jumper cable to take the current from the transistor to the ground, we get that the LED will turn off. This is what a NOT gate signifies. When the switch is connected, the LED will be off, while in a NOT gate, when there's no switch connected, the LED will be on.